Hello everyone, today we're going to talk about monomials. But first of all, we need to understand what is a literal expression. A literal expression is an expression that not only includes numbers and mathematical operations, but also letters. So we have numbers such as 6, 5, -2, 3.5, these kind of numbers. We have operations, just plus, minus, division, multiplication, and so on and so forth. But what we now have are letters. And these letters often represent some sort of unknown quantity or a variable quantity. And we'll see this better in the following video, theory video, about operations with monomials. In particular, a monomial is a literal expression in which only multiplications are allowed between numbers. And the powers of the letters are only natural numbers. So this might seem a little bit complicated, but it really isn't. Let's have a look at this slide to see better what I mean with this definition. When we have 1/2 a to the 6th power, we see that the only operation is multiplication, okay? So 1/2 times a to the 6th power. So we only have multiplication. 1/2 is, we don't consider that division because the important is that the multiplication with letters, okay? So 1/2 is like a number, it's 0.5, and in this case we can multiply it by the letter, okay? While in the example below, 3x over y, this is not allowed because we have a division with letter. This is the difference. Then the exponents are only natural numbers. This means that the exponent number can only be a number ranging from 0 up to positive infinity. However, we cannot have negative numbers and we cannot have numbers with decimal parts. So, for example, if we have 3.2 or 0.5, 0.333, these numbers are not allowed as exponents. Okay, so we can only have a to the 7th power, a to the 10th power, a to the 1 power, maybe. These are the only numbers allowed for exponents. Now we can see 2ab a to the 4th power. In this case, we only have multiplication. We have two letters repeating, which are a, but this is still allowed because it is a multiplication. A to the 4th power times a would be equal to a to the 5th power, if you recall the properties of exponents. So this is definitely okay. Then we can see negative bx b squared. Same things go here. So b times b squared is b to the 3rd power. And that negative sign is allowed because it's a constant. Okay, so it would be -1. It's like 1/2. In 1/2 we have division, but it's not with a letter. It's just with a number. So this is allowed. And in the end, we have 5 plus 3 over 4 all multiplied by a, and this is actually okay because 5 plus 3 over 4 is a number. So if you sum 5 to 3 over 4, you will get a quantity that will be multiplied by a. And so we have a monomial in this case, because once you do that sum, you will get one number, and eventually the only operation there will be a multiplication. When we could possibly have numbers as monomials, so for example 6 can be a monomial, 9 can be a monomial, 0 could also be a monomial because it's also called the null monomial. The null monomial because it's 0, it doesn't represent any quantity specifically. Here instead we can see some examples which do not represent monomials. As we said before, 3x over y. The second one is not a monomial because when we do 2 times a plus 2 times b, then we will still have that plus sign in between, because we cannot sum a and b, and we will see this more clearly in the following video, as I said before. And the same thing works also for the other two examples. Now, we can reduce a monomial to normal form. What this means is that we write a monomial as product of a number and one or more letters, which are different one another. So let's see this example. 6a, 3ab. This is a monomial because we have numbers. The exponents in this case would be 1, so they are okay, they are greater or equal to 0. There are no divisions, only multiplication with letters, so we are fine. This is a monomial. But as I wrote more clearly, we can express this monomial as a series of multiplication. And we can see the multiplication 6 times 3, which is 18, and then we have a times a, which is a squared times b. In this case, we just reduce a monomial in normal form. Okay? The numerical factor is called a coefficient. So in this case, 18 is the coefficient, while the letters represent the literal part. So a squared b is the literal part. When we don't have any number in front of a letter, or there's the negative sign, then we assume that that number is the coefficient is 1. So in this case, ab squared, the coefficient is 1. We can see a number, we usually omit the number 1 or negative 1. And then we have negative c squared z to the 5th. In this case, we have negative sign, but there's no number before, so we can see that the coefficient is 1. Negative 1 c squared z squared. But usually, we do not type the number 1. We just say c squared z to the 5th, negative c squared z to the 5th. Okay? This is how we usually do that. Now let's see the degree of a monomial. The degree of a monomial with respect to a letter is the exponent of the letter, simply, while the overall degree is the sum of all the exponents. So let's see these examples so that it's more clear. 4/3 a squared b. The overall degree is the sum of the exponents. So the exponent with respect to a is 2. And the degree with respect to b is 1, because we usually don't write, as in multiplication, we do not write 1 as an exponent. So b has the exponent 1. And so the overall degree is just 2 plus 1. Then negative a to the 4th. The degree with respect to a is 4, and the degree with respect to b is 0. Because if we raise b to the power of 0, we get 1. Okay? And a to the 4th times 1 is a to the 4th. Okay? Nothing changes. So we can consider that. And so the overall degree will be 4 plus 0, which is 4. Now, in the final example is pretty much the same as the previous one, because the degree with respect to a can be considered 0, because a to the 0 is equal to 1, and b times 1 is equal to b, and the degree with respect to b is 1. So the overall degree will be 1 plus 0, which is equal to 1. Now let's see just a final topic, which are similar monomials, and this topic is pretty important, I will say. So monomials with the same, exactly the same little part are called similar monomials. Okay, the same little part, of course, when we talk about reduced monomials. Okay, reduced normal form polynomials. And when they contain the exact same variables with the same powers, then we can call them a similar monomials. Sorry. So we can see that 3a to the fifth and negative a to the fifth are similar indeed. Why? Because we can see that maybe I can show you a bit clearly. Here we have a to the fifth and negative a to the fifth. So in this case, the exponents are equal, and the letters are equal. So this is okay. The same thing goes with 3z and 5z. The exponents in this case are 1, okay? 1 is equal to 1 and z is equal to z, so this is fine. But the problem is here, because a is not equal, is actually equal to a, but 5 is not equal to 4. This is not okay. These are not similar, because letters are the same, but the exponents are not. Then a is not equal to b, okay? And 2 is equal to 2. But the exponents are the same, but letters are different. So we cannot call these two monomials similar monomials. They have different literal parts. So for today, that's it. I hope everything's clear. So write in the comment section below if you have some doubts. See you in the next video.